So as we enter into the world of probability distributions, when we're entering into any kind of new statistical subworld, the first thing that we're going to define is going to be our mean, and the second thing is going to be our variance. So our mean, representing our central location in the data, and the mean of a probability distribution, represented by lowercase mu, also known as the first symbol of the BitTorrent application. Not that I would know anything about that. So the lowercase mu is going to be a summation of each individual outcome times the probability of that outcome. This is equation 6-1 in your text. So the second question we ask after the central location of the data is, what is the spread of the data, right? The variance. Is it a tight fit narrow band of data, or is it a wide sloppy data set? So the variance of a probability distribution is represented by sigma squared, and this is equal to, again, summation symbol. I'm just being a little bit neater in the way that I'm drawing it today, but every time I do a sloppy E that kind of looks like a backwards 3, I'm trying to do a summation symbol, but I'm just being very fancy today. So the summation of, and the reason why I'm using brackets is because we have so many parentheses in the inside here. It's just, it'd be too confusing. So anytime you have parentheses, you want to use brackets, and then if you still have extra stuff, then you're going to want to use curly brackets. But we don't have extra stuff, so we don't need to use curly brackets yet. So this is our particular event minus mu, our mean. And then remember, we square variances, right? We want to reward those points that are within 1 unit of distance, and we want to punish those points that are further than 2. We also want to level the playing field and have apples to apples instead of apples to oranges. We don't want to have negative variations canceling out positive variations. So we square them to get rid of the negatives. We also square them to reward those points close to the mean and punish those points further away. We multiply this squared deviation by the probability of that event. And this is equation 6-2 in your text. And then the standard deviation that we have is going to be the positive square root of the variance. So the mean of a probability distribution is the long-run average of a random variable. So we calculate the mean by multiplying the probability of a particular value of x by that value of x, and we add all of these products together. Of course, we'll do an example because it seems very easy, but anytime we take even the slightest deviation when we're in statistics land, what seems easy tends to be more difficult to do in practice. So we always do examples. So a probability distribution mean example. So we use the example from the book about John Ragsdale selling new cars for Pelican Ford. He usually sells most of his cars on Saturday. He's developed a probability distribution for the number of cars that he expects to sell on Saturday, and we're given that. Number of cars sold on Saturday. And this is our X variable, right? And then our Y variable is our probability. So our function of X, our probability of X. So we have 0 cars sold, probability. He's gathered some data, figured out 10% of Saturdays, he sells 0 cars. 1 car sold, 20% of Saturdays. 2 cars sold, 30% of Saturdays. 3 cars sold, 30% of Saturdays. 4 cars sold, 10% of Saturdays. Do all these add up to 1? You betcha. So the first question that we have to kind of ask ourselves is, what kind of distribution is this? So it's a random variable distribution. And is it continuous or is it discrete? It's discrete, right? You can't sell half a car. So these are taking values that are separated by a distance. Then the second question we're asked is, how many cars does he expect to sell on a typical Saturday? So number of cars sold on a typical Saturday, well, that's really just asking me about the long run average of the random variable, right? So it's asking me about the mean. So how do we calculate our mean? Well, obviously we can use Excel, right? We can use advanced calculators and so on and so forth. We can probably even use Google these days. But the long way, we would take each individual value and we'd multiply it by the probability of X. Oh, the other change that I made, I knew I made 2 changes. You can now exit and use Excel. You can both use your ebook and Excel. So expect everybody to crush it. Okay, so 0 times 0.1 is going to give us 0.0, right? Anything times 0 gives us 0. That one's easy. 0.2 times 1, also easy. Anything times 1 is just itself, 0.2. 0.3 times 2 is going to be 0.6. 0.3 times 3 is going to be 0.9. And 0.1 times 4 is going to be 0.4. We add up all these things together. 9 plus 0.4 plus 0.6 plus 0.2 gives us a average, a mu, of 2.1. So we can say he can expect to sell a little, you can expect to sell 2 cars. You can't sell 0.1 car, right? Now, what we could say, too, is since we do know that average is mu is equal to 2.1, if we wanted to be more specific, we could say in the long run, over, say, 50 Saturdays, he would sell, and then you would take that 50, and then you would multiply it by that 2.1 to get 105 cars. But honestly, either answer is correct. Because, again, you can't sell 1/10 of a car. I mean, I guess you can at a junkyard, but not at a regular car dealership, right? And so our third question that we're asked, right, anytime we have these kind of distributions, we want to know what's the central moment. We want to know how wide or narrow is it distributed. What's the spread, right? So the computational steps for calculating the variance are as follows. So we are going to get rid of this part. also get rid of this. We will say mu is equal to 2.1, just to have that there because we're going to need that. We'll change colors. We'll do the variance in green and get going. All right. So the variance, we're going to need 3 extra columns. I know, so much work. So the first column is going to be our x value minus mu. So we're going to take 0 minus 2.1. We're going to take 1 minus 2.1. We're going to take 2 minus 2.1. 3 minus 2.1. 4 minus 2.1. And then we're going to take these values and we're going to square them. Negative 2.1 squared is 4.41. Negative 1.1 squared is 1.21. Negative 0.1 squared is 0.01. 0.9 squared is 0.81. And 1.9 squared is 3.61. So now we have to take these values and we have to multiply them by the probability. So we multiply 4.41 times 0.1, we get 0.441. Multiplying 1.21 by 0.2, we get 0.242. 0.01 times 0.3, 0.003, 0.81 times 0.3, 0.243, and 3.61 times 0.1 is obviously 0.361. We add all these up together to get our variance, theta squared, sigma squared, 1.290. To get the standard deviation of this, the positive square root of our variance is going to give us 1.136 cars. So the reason why we like standard deviation rather than variance is because variance is in cars squared. It's a very odd unit to try to interpret, right? And especially since we have a mean that's in the number of cars, and also we can just understand like a singular car. What is a car squared? I mean, a foot squared makes sense, but a car squared doesn't really make much sense, right? So we take the square root to get it in the units that we understand that make sense, and the units of the mean. Questions on discrete, continuous, random variable probability distributions, calculating the mean and the variance and the standard deviation?